Okay, hopefully you have printed your review guide by now, and if you did not get that done, you may want to pause this video and go get that printed. If you don't have a printer, then just write it in a notebook. Some of these key points, or underline them in the notes we've already taken. Corresponding sides must have the same scale factor. So if you make a scaled copy, each copy will increase or decrease by that same amount, which is called a scale factor. And corresponding angles in scaled copies have to have the same angle measures. These are two key facts that we learned in this unit. You must have the same angle measures, but the sides will increase or decrease by a scale factor. Okay, we have this picture. Figure 2 is a scaled copy of Figure 1. For each statement, determine whether it is true or false. So segment ED, we're talking about this one. Is it twice as big as ML? Well, I would have to know what the scale factor is. So look for two sides that you do know the numbers on. So I would say 6 and 2 here. So figure 2 is the scaled copy. Always label. This is the original. We go into the copy. So you do copy, which was 6, over the original, which is 2, and you get 3. So this segment should be 3 times bigger, not twice as big. So this would be false. It is 3 times bigger. What about the measure of angle L? Is it twice the size of angle D? No, what did we say up here? Corresponding angles must have the same measure, so false. The angles are the same. And then we're going to skip and go to D and E. And I'm going to have you do C and F on your own later. The perimeter of figure 2 is 9 times larger than figure 1. Well, remember, the perimeter should be the same, increased by the same amount as the scale factor. So our scale factor, we said, was going to be 3, 6 divided by 2. So it should, this is false. It is 3 times larger. And then the area is 3 times as large. Well, when we did rectangles, I don't know if I went over this enough, but you have length times width. Well, if this shape is twice as big, it would be 2 times the length. And if this is twice as wide, it would be 2 times the width. So now you're multiplying 2 times 2, and it would be 4 times as large. So it is, the scale factor was 2, but the area would increase by 2 squared. 2 squared, or 4 times as much. So if my scale factor is 3, we would do 3 squared, because it'd be 3 times the length and 3 times the width, which would give me 3 times 3, or 9. So this is false. It is 9 times larger. So perimeter increases by the scale factor, but area increases by the scale factor squared. Okay, to find the scale factor of 2 scaled copies, you need to take the length of the copy divided by the length of the original of the corresponding sides. So it's always length of the copy divided by length of the original. If there's anything you need to remember, this is going to be a key point in finding those scale copies and the scale factors. Sorry, not the scale copy, the scale factor. All right, question 5. Rectangle X measures 8 inches by 5 inches. Rectangle Y is a scaled copy of rectangle X. We don't have rectangle Y, but we're just going to do X here. It's 8 inches by 5 inches. And then we're going to see if these could be scaled copies. So I'm going to do one with you, and then you're going to do the rest on your own. Okay, so if it's 15 by 10, this is my copy, right? Rectangle Y. So I'm going to do copy over original. 15 is the long side. And then you do 10 over 5. 10 over 5 is the same as 2, but 15 divided by 8 is not 2. So this is not equal to 2, so no, it's not a scaled copy. Why not? The scale factors are not the same. Okay, the scale factors are not the same. I'm going to make my pen keeps going. Okay, and then it gets lighter. Okay, 2 inches by 1.25 inches. We'll do 2 of these. So I'm going to start with the 2 and put it over, this is the longer side, so 2 over 8. Is that the same as 1.25 over 5? And again, use your calculator, divide these. 2 divided by 8 is 0.25. 1.25 divided by 5 is 0.25. So yes, these are scaled copies and our scale factor is 0.25. Scale factor. Okay, who knows what fraction that is? That should be the same as the fraction 1/4. Okay, 0.25 or 1/4. Then number 5, rectangle A is 10 centimeters long and 8 centimeters wide. Your friend draws a scaled copy that is 40 centimeters long. So what is my scale factor? It went from 10 to 40. So we're multiplying by what? 10 times what is 40? Or you can figure it out by doing copy was 40, original was 10, 40 divided by 10 is 4. Either way, 2 different ways. So 4 is my scale factor. What is the perimeter of the new figure? So your perimeter, let's find the perimeter of the old figure. We had 10, let's just make it here. We have 10 and we have 8. And then she drew a copy that was 40 long. Well, we got to multiply by the scale factor of 4 to get to 40. So 8 times 4 is 32. So the perimeter of the new shape would be 40 plus 40 plus 32 plus 32. You add up all the sides, and you would get 80 and 64. If I add them together, you'd get 144. What is the area? Well, area is length times width. So you need to take 40 times 32. And that is going to give you your new area. Let me quickly do that. (1,280) centimeters squared. Your units are always square units when you're talking area, because you have length and width. Okay, for number 7 through 9, The larger figure is a scaled copy of the smaller, and now you're just finding corresponding angles or segments. So the key point here is to match up the letters. So when I'm looking at angle ABC, I'm going to find the same letters that correspond here, and it's going to be angle GHI. I'm just finding the same ones and matching letter to letter. And then you're going to find some segments. Find the corresponding line segment. Same thing. Match up the points and the numbers. I'm going to let you do that one. Number 9. Use the figure above to answer the questions. What is the scale factor? So again, let's go. The larger one is the copy of the smaller one, it says. So label, which one's the copy, which one's the original. And then we're going to find two sides that both have numbers that we can compare. So here's two sides right here. We have 0.8 and we have 2. So I can do copy was 2. The original was 0.8. 2 divided by 0.8 is 2.5. That is my scale factor. And then you can use that scale factor to find the length of each of the sides. Oh, here, let me move this down so you can see where I wrote that. To find the scale copy, always do copy divided by original. And then you're going to find the length of 3 different sides using this scale factor. Keep in mind which lines should be bigger. The ones over here, these should all be smaller than the ones in the original should be smaller numbers than the ones in the copy, because the copy's bigger. So kind of use common sense there as you're doing that. And then the last one, for each situation, describe the scale factor. More than 1, less than 1, or equal to 1. And we've talked about that in class. Go back to your notes if you need them to answer that question. So I'm going to let you finish your review guide, and then I want you to enter the answers into the assignment.